Hello everyone, today we are doing SPM differentiation. Okay. First, let's look at this equation. Y equals to 2x plus 5. This is a linear with gradient equals to 2. So, dy dx is gradient. Gradient equals to 2. Next, y equals to 4x squared. Now, this is not linear anymore. This is a quadratic. Quadratic has different gradient at different point. So, how do we do differentiation? How do we find gradient? Dy dx is the power, bring it down, times 4, reduce 1, which is 8x. At different value of x, you have different gradient. 8 times 2, 16. Okay, next, question number 3. Now, this is polynomial. Y equals to 3x power of 4. Same thing, to find the gradient, dy dx, the 4 bring down, 4 times 3, 12x power of 3. Remember this one? This is a linear, so the gradient is 4. Alright, next, type 4, question 4. Y equals to 4x times x squared plus 3. Now, if you can expand, let's expand. Y equals to 4x cubed plus 12x. Let's do differentiation. Dy dx equals to 4 times 3, 12x power reduced by 1, and this is a linear, plus 12. Next, number 5. Let's look at this question. Now, this one we cannot expand. We cannot expand, right? If we cannot expand, we need to use this technique. Dy dx, we call it group differentiation. Group differentiation, the power, again, bring it down, becomes 6. Right again. You do one extension. Dot what? 4x minus 5 is in the group. Let's do the dy dx here. You will get 4. This 4 is your extension. 7 times 4 is 28. 4x minus 5 power of 6. Next, number 6. Y equals to 2x plus 3. Now, this we have two groups. Can we expand? Yes, we can. So if we can expand, let's expand it. Become 8x squared plus 10x minus 3. And then we do the simple differentiation. 16x plus 10. Okay, there is another method. This method is let's call this front and we call this back. When we do dy dx, we copy the front, we differentiate the back. Okay, do the same thing in reverse. Copy the back, differentiate the front. Let's expand this. you get the same answer. Okay, let's look at the next question, number 7. This one, y equals to 4x, is a quotient, bahagi. So you have to use another formula. Okay, so let's call this top and bottom. When we do dy dx, we copy the bottom and the bottom again square. All right, let's start. Copy the bottom, differentiate the top. This time is minus, be careful, it's minus. The other way around, copy the top, differentiate the bottom. Then we get 20x plus 28 minus 20x over, and you have 28 over 5x plus 7 square. Okay, next, let's look at question number 8. Question number 8, this is a quadratic, simple. Okay, then the question will ask you, find the gradient of the tangent at a certain particular point. Okay, this is called tangent. At this particular point, let's say x equals to 1. Okay, x equals to 1. Okay, or sometimes they ask for find the gradient of normal. This one is normal. Find the normal when x equals to 1. Alright, how to do that? Same thing, dy dx, again, it is 6x plus 4. When x equals to 1, dy dx equals to 6 times 1 plus 4, that will give you 10. The gradient of the tangent is 10. Okay, gradient of tangent. Okay, next. Now again, this is a quadratic. The question could ask you for the normal or tangent or stationary point. Stationary point or maximum point or minimum point. Okay, this is called stationary point. Or dictate minimum or maximum. Okay, at this point, dy dx is 0. The gradient is 0. Okay, let's do it. Dy dx equals to 3x squared plus 12x plus 7. Oops, sorry. The y equals to 3x squared plus 12x plus 7. Then we start to do differentiation. Dy dx is 6x plus 12. Okay, I want to find this point. Dy dx equals to 0. So we mention here for maximum or minimum point. In this case, it is minimum point. Dy dx equals to 0. So we know 6x plus 12 equals to 0. So x equals to negative 2. At this point, the x equals to negative 2. If they want you to find the point, then you need to find the y value. So the x equals to negative 2. Should we substitute into here? No. We substitute the x into the equation of the curve. Y equals to 3 times negative 2 squared plus 12x plus 7. Negative 12, oh, positive 12, minus 24, plus 7. That will give you negative 5. Okay, so the y is negative 5, so the coordinate is negative 2 and negative 5. Let's continue with question number 10. Now, question number 10 is application. Application, usually they will give you a certain situation. Okay, in this case, they give you a box with a square base. Okay, that means x, and here also x, with a total surface area of 216. Surface area 216. Alright, so for differentiation here, they want you to show the volume given by this. Alright, so geometrical shape, you need to know the a few things. First is volume. The second thing is the surface area. So what are the common geometrical shape? It's sphere, cone, and cylinder. Yeah, these are the common shapes that you need to know. The volume of sphere, the area of sphere. Okay. Now this is given a cuboid. All right. So the surface area given is 216. Okay, let's start with whatever given. Area is height times x, x h, and the other side also x times h, and here also x times h. The height behind here also x times h. So you have 4x times h plus the bottom plus the top, that will give you 2x squared. X squared times 2. Okay, and then the question asks you to show the volume. Volume equals to x squared times h. So how do we get rid of h? Area is given 216, 4x h plus 2x squared. So you know h equals to 216 minus 2x squared over 4x. Okay, of course you can simplify. Then we can substitute into the y, the v, x squared times 216 minus 2x squared over 4x. When we simplify the whole thing, x squared over 4x, 216 minus 2x squared, it will be 54x minus half x cubed. Okay, shown. Part 2. Find the value of x that makes v a maximum. Maximum, do you remember? For maximum, the dy dx equals to 0. Equals to 0, gradient equals to 0. So v equals to 54x minus half x cubed. Let's do dv dx. dv dx is 54 minus 3 over 2 x squared. For maximum v, dv dx equals to 0. So you get 54 minus 3 over 2 x squared equals to 0, and you get x equals to plus or minus 6. In this case, x cannot be negative 6. So you write x equals to positive 6. This question asks for the value of x, but sometimes the question also asks you, hey, find the value of maximum volume. Then you need to substitute the x into the volume, which is this one. Okay, this is the application type 10. Type 11, rate of change. Rate of change. How do we know this kind of question will come out? Okay, by looking at the question, you see the per second. That is the rate of change. Okay, so whenever you see this, we always read the question carefully and identify the geometrical shape. This is a sphere, rate 0.2. Very important. So let's write down. They give you the rate, the radius increase at a rate, dt is rate 0.2 cm per second. The unit is cm and second. So what is the question? The question asks you to find the rate of change of the surface area, okay, when the radius is 4. So the question asks you to find the dA dt. So here you need to know this formula. dA dt is dA dt. Okay, split them just like normal fraction. So what do you want to put in here? So I will put in dr. Why? Because I have the dr dt. Okay, but I don't have dA dr. Okay, so first, before I do this question, I want to find dA dr. Area of a sphere. Area of a sphere is 4 pi r square. Okay, area is 4 pi r square. Volume is 4 over 3 pi r cube. So I want to do what? dA dr. I want to find dA dr. 8 pi r. Done. Alright, then I want to find dA dt. The question asks for dA dt. Okay, let's do dA dt equals to dA dr dr dt. dA dr is 8 pi r. dr dt is 0.2. That will be 1.6 pi r. Do we have the r? When r equals to 4 cm, dA dt equals to 1.6 times pi times 4. 6.4 pi cm per second. Sometimes they ask you to write your answer in terms of pi. This is the answer. But sometimes they ask you to write your answer in 3 decimal places. So you write 20.169 cm area, area like this. Okay, let's look at the last kind of question that will come out in SPM. Small change. Small change. Okay, small change in this case means the radius change a little bit. Okay, the geometrical shape we use here is cylinder. Okay, the height is 12 cm fixed. What is the variable? The radius is a variable. Radius change from 4 to 4.05. That means radius equals to 4 and then change to 4.05. you increase a little bit, we call it delta. Delta R is positive 0.05. Then only you become 4.05. Okay, remember this. So for small change, there is only one formula you need to remember. That is delta y over delta x is dy dx. Or in this case is delta v over delta r is dv dr. How do I know that I want to use this one? Okay, now read the question again. Cylinder, find the small change in volume. Small change in volume. The question asks you to find delta v. When the radius change, that means delta r is 0.05. So I know I want to use delta v over delta r. Let's start. Okay, volume is formula pi r square height. You know the height is given a fixed value. R is not fixed value. R is a variable. R change. R is a variable. So we can find dv dr 24 pi r. Okay, so come to this one. Delta v over delta r is 24 pi r. So I want to find delta v. So 24 pi r times delta r. So what is my r? My r is 4. And what is my delta? Small change 0.05. Press your calculator. You get 24 over 5 pi. Volume cm cube. Okay, volume cm cube. The unit is cm cube. Then sometimes they ask you write your answer in terms of pi. Sometimes they ask you in terms of in 3 decimal places. Then your answer could be 15.080 centimeter cube. Okay, that's all about differentiation. These are the only type of question that will come out in exam in your SPM. Thank you. Bye bye.